Hi, my name is Ali Abedi. This is a joint work with my colleague Omid Abari. In this talk, I will present our paper, Wi-Fi says hi back to strangers. Before I explain our findings, let's briefly review how Wi-Fi networks work. A Wi-Fi network consists of an access point and some Wi-Fi devices. When a device sends a data packet to another device, the receiver checks to see if the packet was received correctly. If that's the case, it generates an acknowledgement and it sends it back to the sender to notify it that the packet was received correctly. A Wi-Fi network is typically protected by a password, so we expect all communications to happen within this network. Specifically, if a device is not associated with this network, like the laptop on the right, it should not be able to communicate with the devices in our private network. However, to our surprise, we found a different behavior. We found that if we send a fake packet to a device in another network, surprisingly, it sends back an acknowledgement for our fake packet. We call this behavior polite Wi-Fi because Wi-Fi devices respond to the packets they receive from any stranger. We tested this on some devices in our lab. But how many devices could we test? 1, 10, 20, 30? Well, to make sure this is a widespread problem, we ran an interesting experiment. We thought there are many devices in the city, so let's see if these Wi-Fi devices respond to our fake packets. We drove around the city and sent fake packets to nearby devices to see if they are vulnerable to the polite Wi-Fi behavior. We recorded if they respond to the fake packets. Our script finds new devices as we drive and test them. We drove in low-density residential and commercial areas for about 1 hour. Here, I list some of the devices that we found that responded to our fake packets. Not to be confused with the sponsors of sitcom. In total, we found over 5,000 devices that are vulnerable to the polite Wi-Fi behavior in our experiment. But what are the consequences of polite Wi-Fi? We have identified many threats and opportunities in the paper. Here we briefly review some of these threats. Polite Wi-Fi can create many threats. For example, polite Wi-Fi can be used to infer the text being typed on a smartphone or a tablet. We have also found that it can be used to drain the battery of an IoT device. In addition, polite Wi-Fi can couple with many Wi-Fi sensing techniques such as breathing rate and heart rate estimation and gesture recognition to steal privacy-sensitive information. Here, I'm going to explain keystroke inference and battery drain attack as an example. Suppose that we have a victim's device. We want to infer what is being typed on this device. An attacker sends fake Wi-Fi packets to the victim's device and receives the acknowledgements. The attacker can then analyze the signal of these acknowledgements. For example, it can measure the channel state information or CSI. Previous work has shown that the movements of hand and fingers create unique patterns in wireless signals that can be used to infer what is being typed. So we talked about these attacks, but are they practical? Well, to answer this question, we ran an experiment where the attacker and the victim are in two separate rooms separated by a drywall. The attacker sends fake packets and measures the CSI of the received acts. I now explain the results that we got from this experiment. The experiment was around 40 seconds. The x-axis shows the time, and the y-axis shows the CSI amplitude for one of the subcarriers of the OFDM modulation. We use a tablet in this experiment. The tablet is on the ground at the beginning of this experiment, and as you can see, the signal is very stable, around 25 dB. Then somebody approaches the tablet and picks it up. This creates sudden and sharp changes in the CSI, as expected. We then hold the tablet for a while. You can see that there are some slow changes because of small movements. We then start typing on the tablet for about 10 seconds. Interestingly, there are very unique patterns created by typing on the tablet, suggesting that it might be possible to infer what is being typed on the tablet. We then put down the tablet on the ground and it stays there for a while, and the signal becomes stable again. This experiment is very interesting because we had no control over the victim's device. But as you can see, we can analyze the signal we are receiving from the tablet by forcing it to send acknowledgements and see what's happening on the tablet or around the tablet. This experiment shows that it is possible to use polite Wi-Fi to create privacy threats. I now explain another threat created by polite Wi-Fi. Since polite Wi-Fi can force a device to transmit acknowledgements, can it increase the power consumption of the target device so that its battery is drained? We test this idea on an ESP8266 Wi-Fi module, which is an ultra-low power Wi-Fi module used in many IoT devices. We send back-to-back fake packets to this module and measure its power consumption using an accurate multimeter. I now explain the results we got from this experiment. On the x-axis, we show the number of packets we transmit to the device per second. Then the y-axis shows the power consumption of the module. In the first phase, we do not send any fake packet to the device. In this case, because the device doesn't have anything to do, it is in a power saving mode. In this mode, the module tries to turn off the radio as much as possible to save power. In this case, the power consumption is only around 10 milliwatts. Then we start transmitting some packets to the module. We realize that if we at least send 10 packets to the device, we can prevent it from going back to the power saving mode. This significantly increases the power consumption to around 230 milliwatts. Then we increase the number of packets we transmit to the module. As you can see, when we send 900 packets per second, the power consumption goes to 360 milliwatts. This is a 35x increase in the power consumption of the module. This experiment shows that polite Wi-Fi can enable the battery draining attack. Well, now you know Wi-Fi says hi back to strangers. Polite Wi-Fi creates many opportunities and threats. In this talk, I touched on some of these threats. We would love to hear from the experts in the privacy and Wi-Fi sensing areas to find out what they think about polite Wi-Fi. Thank you.